So let's take a look at configuring client HyperV. So HyperV can be used on both the Windows client as well as a server for hosting additional operating systems. So what is client HyperV? Well, it provides as it says, the capability to share a computer's hardware with one or more operating systems that run inside the same computer. So we suddenly don't have this need to dual boot or quad boot or tri boot a computer where we're limited to using just the one operating system. In this case, we'll have a base or a host operating system, and inside that use HyperV, simple software application, to run additional operating systems. So the technology is called a hypervisor, and it keeps the host or parent operating system separate from all the virtual machines installed. So essentially, it's like having multiple machines. Of course, that's exactly what it is, utilizing a single set of hardware. So to install it, it requires 64-bit operating system, and it can host other 64-bit operating systems, such as Windows Server 2012, 2012 R2. To go through the install process is pretty easy. We just go out to Windows Features. It's not on by default, and we select HyperV, and we'll get the management tools and the PowerShell for it as well. So we just do that install. Now, let me bring up something about the installation process. Note that HyperV does not play well with VMware. Okay, so the technologies are the same. It's recommended. Some people say you can. I haven't been successful with it in running VMware and HyperV on a single machine. However, I can run HyperV with VirtualBox if I choose another virtualization software. So this just, installing HyperV, it shows the HyperV applications. The most important one is the HyperV Manager. That's where we manage all of these virtual machines that we've created. So it's a Microsoft Management Console. It's a snap-in, and essentially gives us 5 areas to manage our virtual machines. So first of all, whichever host we're connected to. HyperV Manager not only allows us to manage machines locally on, say, the desktop or laptop we're on, but we can also connect to remote machines that may have virtual machines on them as well. So we can connect to different hosts. We can look at all the virtual machines. Now, a virtual machine, of course, there is one sort of snafu here. First of all, we do have to have ample memory and ample disk space, because as we'll see, each virtual machine is going to utilize or capture a static amount of memory to be used while the virtual machine is running. So keep that in mind. We definitely need a base operating system or host that has enough hard disk space and memory to run these. So the HyperV Manager, the hosts, again, connect to any number of HyperV host computers. The virtual machines lists all the virtual machines on that host. And then, of course, the actions we can take in managing those virtual machines. Snapshots, we'll talk a little bit more about snapshots later. They're really cool. And then, of course, VM tabs, a window into the currently selected virtual machine. And each tab shows a different area of functionality. So if you want, go ahead and pause this. You could read the rest of those slides. So a virtual machine is essentially 3 components. Has to be 2. You have to create a virtual hard disk. That's really nothing more than a file that has all the operating system files, applications, configurations, etc. And then there's a little XML configuration file. You can kind of think of that as the BIOS. So that's what it goes to know how much memory needs to be allocated, what's the disk size, where the virtual hard disk is located, etc. And then again, a little bit more on snapshots. We'll talk about that here in just a minute. So all of these can be created and, yes, managed by HyperV. So we can use HyperV to create a brand new virtual machine. So in creating a virtual machine, that doesn't mean that the operating system is automatically installed. So we can think of the virtual machine as a shell, as a laptop without an operating system on it. Pretty useless, pretty impractical. So work through the virtual machine settings to ensure that the virtual machine has the correct operating system and hardware characteristics. So let me give you an example. If we create a virtual machine of an older OS like XP, we may only need to give it 256 meg of RAM. We certainly don't need a huge amount of hard drive space, so we can customize these. And what you'll find is that a lot of the virtualization technologies have wizards built in that says, oh, okay, what operating system are you installing? Oh, I'm installing, Microsoft XP. All right, well, we have some default settings here that say, we're going to give the machine allocate 512 megs of RAM and a 10 gig hard drive, for example. So we can do those, but those are modifiable. So here's where we would go into the machine settings and modify this. Where's the BIOS, how much memory. Now, of course, like with any other computer, the more memory you give it, the more efficient, the faster it's going to run. So, and then hard drives. The great thing about a virtual machine is we can create virtual hard drives, which we'll talk about in a minute. We can connect those to a host OS. We can connect it to a virtual machine. Really great. So if we run out of space, now we'll talk about the efficiency here in a minute of what might be best based on the application of the server or the client that someone's going to run. We can decide how much processor or how little processor. Do we use IDE or SCSI? We'll see that there is an advantage to one over the other. How is it going to connect? Is it going to be autonomous? Is it going to connect to other machines? Is there other hardware that's on my host operating system, such as the ability to connect a USB drive? Do I want the ability to access that USB drive from the virtual machine? So that leads us to snapshots, and snapshots just are really cool. This is one of the great advantages of, say, creating a personal virtual network to try things on, test things on, learn new software or hardware. And here's a great example. So snapshots are essentially a feature, provided by HyperV, provided by all virtualization software actually, that enables the user to take a point-in-time image. So what it's basically doing is saying, okay, here's a point in time. I'm going to take and copy that virtual hard drive so that I can restore to that. So a great example might be, I put up a new Windows 10 client. I'm playing with it. Before I start playing with it and messing it up, I take a snapshot. Then I go in and I just thoroughly mess the thing up, and I can simply go back to that point in time by instantiating that snapshot. So there's kind of a great example. From a software testing standpoint, I want to see how something installs. Let's say I want to practice installing Active Directory on a Server 2012 R2. So I take a snapshot before I start that process, and I do the process. I understand it. It went well, whatever the case, or it didn't go well. I can go back to that snapshot and do it again. So virtualization is great. When you're working on your MOAC labs, you're working on virtual servers. So, changes fail. There's a great reason for it. So we can, again, manage snapshots. It gives us sort of a tree of the, post-install initial snapshots, all the snapshots that are available. Now, keep in mind, as we create a snapshot, we're storing a lot of stuff on disk. So kind of keep that in mind. Settings, go ahead and pause this and read this. We can rename snapshots, apply them. One key point is, remember, if you took a snapshot when the machine is off, then when you instantiate that snapshot, the machine's going to be off. You're going to have to, start it up. So deleting snapshots, deleting the whole tree just to keep things clean and efficient. Granted, we have terabytes and terabytes of disk space, but it doesn't mean we need to save stuff that we're never going to use again. So now, one thing that's come to light that really makes this valuable in a production environment is the idea of virtual switches. So how is it we connect these virtual machines? Sometimes we want these virtual machines and things on them to be autonomous to just the virtual environment. For example, if I fire up a domain controller with DHCP and DNS, I don't want that affecting my production network, So I want to be able to create an environment where they can work together. However, what if I do need to connect with the internet? So, definitely provides security, isolation, service levels. You can go through the, different features of the switch. So there's our DHCP guard, protects against malicious virtual machine, representing itself as a dynamic host, a DHCP server basically, and issuing IP addresses out. More features for you to look at here and understand. And then there's the switch types. So there's basically 3 types. One is external, so it connects directly to the physical NIC, and the virtual machines can communicate with the external network. That means I can put a virtual machine on, just like I've done in my videos, and I've completed all the updates. So currently they're sitting in an external environment. However, I don't want to fire up the DNS and DHCP because then it's going to affect the host, and it's going to affect other machines on my network that might get an IP address from there and suddenly not be able to, say, get to the internet or get to my media server or whatever the case may be. Internal allows virtual machines to communicate together with the host, so just the host and the virtual machines, and then of course private, just the virtual machines communicate together, leaving the host out of it. So as I create a real test environment, I'm going to go ahead and use that private switch, create a private switch. I tend to name that switch whatever my Active Directory is going to be called. So you can go through, configure the switch. So the last thing to look at is virtual hard drives. So one of the great things about the idea of a virtual hard drive, simply a file, is that I can add more hard drives when I run out of space, something I can't necessarily do on a physical machine. So, but of course on the physical machine, I have to have enough disk space to host all of these virtual hard drives. So, right now I've got a Server 2012 instance that's sitting at 65 gigs with some software I have loaded. I need to have the physical disk space to do that. So, in order to run, we must have a VHD. We're going to find out that there's 2 types of VHDs. It's possible to boot a physical machine from a VHD if it's running Windows 7 or 8. How cool is that? So here's the 2 kinds. The old standard was VHD. We see this sort of with the file allocation tables, FAT, what FAT supported, and then what NTFS supported. Sort of the same thing here. So, used to be, can be as large as 2,040 gigabytes, just under 2 terabytes. Now we have a VHDX that can go to 64 terabytes. So we literally can have a virtual hard drive of 64 terabytes. That's just crazy. Keep in mind, though, that although on the client machine, primarily our use of these virtual machines may be to, give a client a older client operating system or a unique operating system that runs a specific type of software they need, and we just want to isolate it just to their machine. But on server environments, we can have a base operating system, even a server core with no GUI, and then run HyperV and have all of our machines virtualized on one physical box, and just move those back and forth from physical boxes to create redundancy and to better manage our network. So it used to be if you had a software vendor that said, hey, we've got to be on our own dedicated server so nothing else that you might install messes with us, and that was a standard practice. Now we just throw up a virtual machine, they install their software, and off we go. So a little bit of graphical representation on choosing the disk and disk types. Basically you can read on these. Pause real quick. I'll explain a differencing. Think of it as a parent-child. So I can put up a parent disk that has the operating system and then allow multiple virtual machines to access that, okay, and keep in mind that they would keep changes of that. Now, the problem with that is we certainly wouldn't want to run that in a production environment, because if we lose that parent disk or that parent disk becomes corrupted, it could affect a ton of virtual machines, not just one. So hopefully that kind of makes sense to you. It's read-only parent disk. So parent-child, if you think about backups. So, after creating a new virtual hard drive, you can attach the hard disk to a virtual machine. through the settings. Couple different kinds of virtual hard drives that we should talk about here. And that would be, you know, do we use a dynamic hard drive? So a dynamic disk is one that starts out pretty small. It does have a limit applied to it, but it can grow as we install more software and do more configuration. Now that works well for managing physical disk space. However, a standard server, it's constantly having to say, oh, I've got to grow this file to put more stuff in it, or I've got to grow this file. That can be a performance inhibitor. Whereas if we just create, say, a 60 gig virtual hard drive that is static, it is going to use 60 gigs of space, folks, even if we're only using 5 gigs for the OS, for example. But because it doesn't have to do that process of making itself larger and growing, from a production standpoint, those machines are going to run a lot faster. So a little bit more, you know, for you to look at, but there's a great example of Hyper-V. Take care.